Hello again. So this is the continuation of lesson 4.9 for Algebra 2. So this video is going to cover examples 2 and 3. And again, we're looking at composite transformations on trig functions. So doing the vertical shifts, the phase shifts, the amplitude and the period. Doing all of those things kind of at the same time. So when I look at this example 2, we've got this big messy equation with all kinds of numbers thrown into it. And it says write a rule that would map the original parent function to this function. And when it says write a rule, that's a little misleading. It should really say write rules, because there's two different rules we can write. First up would be our translation rule, right? And that's what's happening to x and y as far as like plus and minus goes. So when I see this inside my equation, x minus pi over 2, I know that in my rule I'm going to have x plus pi over 2 because it's opposite. For the y, it's really this 1.5, correct? That would be my vertical shift, and we don't have to take the opposite of this one because if we were to move it back over with the y, it would be a minus. And so in our rule, we would want it to be a plus, just like it's showing up in the equation now. Okay. So if I was to look at this graph compared to the parent function, I should be able to see that it's shifted over to the right by pi over 2 and up by 1.5. Okay. Now let's do our scale change rule. And so I see inside my equation the x is being multiplied by 2 here. So in my rule, I would say x is being divided by 2. That would have the effect of cutting the period in half. And then the y would be multiplied by 3, as shown by this number right here. Okay. So now I'm identifying amplitude, period, phase shift, vertical shift, and frequency. And each one of those, well, really each one of these 4 things comes from one of these pieces of the rules. And we kind of explored that in the first example. So the amplitude, that comes from the 3y over here. So the amplitude would really be 3 times 1. Okay, and I keep emphasizing saying it that way because I want you to realize this is saying what's happening to the amplitude. The original amplitude is 1, so 3 times 1 is 3. Okay. The period, which the original period is 2 pi, and this horizontal stretch number, or this is really a horizontal shrink number here, that's what's affecting the period. So the period is going to be 2 pi divided by 2, which is just 1 pi. Okay. So again, these are saying what's happening to the amplitude, what's happening to the period. The phase shift just goes back to that plus minus stuff with the x. Okay. So my phase shift would be that I'm shifting to the right because it's positive by pi over 2. And my vertical shift is probably the most straightforward one of them all. That's this one right here. And so that's saying that we would shift up by 1.5 units. Okay. So each one of those comes from a different part of the rule. Now, frequency really relates back to the period. So I'm going to kind of go back to this. Okay. Frequency is the reciprocal of the period. So I'm going to just take pi and flip it over. So the frequency would be 1 over pi. Okay, you did it. You did all the different pieces that were going on in that equation. Example 3 is very similar with one minor difference that we need to talk about. So when I look at example 2, do you see how they wrote this? And it looks kind of awkward here, but it's like 2 and then a smaller subset of parentheses, because that's how we build our transformations. When we're writing these equations, and you saw that in the first example on the previous page, you first apply the translation rule, and then you apply the size change rule to that entire thing. And so this is how we accomplish that, by putting it in parentheses like this. Okay? But if you look at example 3, you'll notice that it's almost like that has been simplified for you. Those extra parentheses are not there. And so what we have to do with this one before we start anything else is write it in factored form. Meaning I need to take this piece right here, this is really what I'm talking about, and write it so that I can see the a value or the effect on the period, the multiplication factor, separately from the phase shift factor. So I'm going to write this thing knowing that the 4 really should be on the outside like this. But if I put the 4 on the outside like this, this is no longer just a 3 pi. Really, I want to take that 3 pi and divide it by the 4. And so this would become 3 pi over 4. And now when I look at this, I can see that scale change factor separately from the phase shift factor. Okay, that's what I want to make sure I can do. So as far as my rule goes, my translation rule would be x plus 3 pi over 4. And for my y, I don't have anything here, and I don't have anything over here with the y, so I'm not translating up or down at all. I'm just going to leave that as a y. Okay. For my size change, or I keep saying that wrong, scale change rule, I see that x is being multiplied by 4. Okay. So in my rule, I'm going to say x is being divided by 4. And then my y value is being multiplied by 3/4. So now, just like before, the only thing that was different there was doing this part, rewriting this way. Now I can follow this rule to answer these questions just like I did up in example 2. So for amplitude, for example, amplitude comes from here, right? And remember, this is really saying we'd do 3/4 times the original amplitude of 1, which is 3/4. Okay. The period, this is what tells you what's happening to the period, and the original period is 2 pi. So I'm taking 2 pi and dividing it by 4, which is going to make pi over 2. Okay. So I'm fitting my entire sine curve in the space between 0 and pi over 2. That's shrinking it pretty significantly. Okay. Phase shift here is this thing, and that is saying that we're going to the right by 3 pi over 4. Vertical shift, we said nothing is happening to the y, so we can just say none or 0 would be fine. And then frequency is, let's take the period and flip it over. So the frequency would be 2 over pi, and we can just leave it like that. That can be my frequency. Okay, so that page wasn't terrible, right? Pretty straightforward there for that one. I'm going to still go ahead and make a separate video for the last example, because the last example has a little bit of everything in it, so it'd be a good one to watch just kind of on its own. But hopefully this was helpful for you.